For the recording. So on Friday we looked into this neural network, right? Neural network with simple neural network, and how the calculation is happening. You know, whatever we see here, the W transpose X.
Sir,
So
are you
whatever
sharing
the
the screen?
sorry.
Are you sharing the screen?
Oh, okay. Visible, right?
Yeah, yes or no?
Give me 1 second. Okay. So we looked into how the calculation happens or how the activation values are being calculated. So I took one row and then showed, right, how exactly the W transpose X is calculating. Even if we have n number of nodes in the second layer, in a single shot we are calculating. Either it is one record or 10 record, the same way the calculation will happen. That point you need to understand. Hope you understood. Any questions there? Either it is one record or 10 records or total data set, the same way the activation values will be calculated. And if you have, you know, two activation nodes or 1 or 10 or 100, it doesn't matter. The same calculation will happen. We have 100 nodes here, then there will be, you know, there are n inputs here. Then there will be n number of weights, and for 100 columns will come. Okay, for each n variables, there will be n number of weights. For each node, there is going to be one column here. Right? For each, you know, L plus 1, this is Lth layer and this is L plus 1th layer. For each L plus 1th layer, there will be one set of weights, one set of distinct weights. Okay, so that point you need to remember, and all that calculation will happen in a single chart. Okay, and we have seen that same calculation on the second part also, and we have seen the back propagation, how exactly it is happening. So it's going to calculate this first and then this, because some parts of the gradient descent calculation are used in the previous layers. So that is neural network, right, at a high level. Now, right, neural network has got activation functions. These red circles and this orange one will have activation functions. No, so far I am actually saying only logistic regression, but there are other activation functions. Logistic or TANH or ReLU or leaky ReLU, and most recently we have got more activation functions. But you know, I am generally using ReLU and leaky ReLU. They are working good. If you have time, right, you can look into the most recent findings also. I'll show you where to look for. Okay.
Yes, sir.
Yeah.
Before going here, sir, can you please go back once? So here the back propagation. So the calculation starts from the back, right?
Ah.
So it starts from the output layer.
Ah. Already.
So it actually checks for the cost, right?
Yeah.
So wherever the cost is, it adjusts thetas or maybe the year U1, U2 in such a way that the cost is low.
Yes, indeed.
So again, that is one step, and it goes to one step back, and there also it checks for the cost.
Yeah. Basically, what is it trying to do is, your question is like how exactly it is trying to see that weight is low in each layer, right?
Yeah, that's right.
So this is the key. dj by du0, dj by du1, dj by dw0, dj by dw1 are the slope of the tangent for the convex cost function. When the slope becomes 0, that means the cost is minimal at that particular theta, at that particular u or w. Okay, that's the it is a we actually are not exactly looking into cost. We are looking into the cost function, the cost function's tangent, slope of the cost function tangent. Got it?
Yeah, so for every layer there is a different slope. Is
Yeah,
that right?
yeah.
Okay, it tries to have the least slope at every layer.
Ah,
Sir, to calculate the slope, basically we need a comparison. So for that, we need to take, it will be internally taking another record between those two. The DJ it will be calculating. Sir, is that so?
you mean to say this part, right? Are we taking one record at a time and then trying to calculate that this equation outcome,
No,
right?
no, no. DJ basically differential of J just to U0. If it
Ah,
needs to calculate, it need a reference, right? Generally, differentiation is nothing but a reference. So that reference is nothing but another record is what I'm thinking.
I
Generally, DJ,
reference.
if we want to calculate a differential on a particular line,
Yes, sir.
you need basically slope, right, sir? So for slope, you need
See,
at least
sir,
2 points.
what we will do is initially everything is calculated as an equation like this. Okay. In this, you substitute those values. That's it. Whatever the x value, the u value, the y value, the b value, everything you substitute here.
Okay.
That's
Okay.
what you're asking.
Yeah, correct, sir.
Yeah. So if you pass, first record you pass, the x will change. If you pass n records, right, the same u, the n records will be passed, and the value is calculated. That's like sigma and all that. The equation gets a bit complex. It'll add that sigma I is equal to 1 to whatever that number of records. I have taken only one record and trying to show here to simplify it. If you are trying to calculate for n number of records, right, you add that whole thing and then try to put it here.
Okay, sir.
Seshiram gar, your doubt got clarified.
Yes, sir.
So there is another question. If you carefully look at it, if at u0, right, if the cost becomes 0, right, this slope becomes 0, then the back propagation might stop. The adjustment might stop at any layer in between, right? No,
Yeah.
no. Yeah, this u get adjustment will stop. Now u1 will get adjusted again. W, but there are terms we are using, right? dj db by dj, dz is used in other layers also, right? This layer, right? This derivative is used in this layer also. So if this becomes 0, right, everything will become 0. So that is a problem with the activation functions. That's what we are going to look at now. Okay, not like not like this one becoming 0. Activation functions derivative becomes 0. Then also the weights will not get adjusted. Yeah, I think I am actually going into some other topic, but your understanding is right, or your question is actually valid, right? We are not exactly looking into the cost function. We are looking into the slope of the tangent for the convex cost function. Our main goal is to make that slope 0. That way, we'll know that we reached the global minima. I think I should open that gradient descent slide.
No, 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 sir.
Fine,
It's
but
okay. Yeah.
give me 1 second. So we are actually doing the same thing. Whatever we did here, this is on linear regression. I can show it, But on logistic regression, I cannot show. So we are trying to reach to a place where the line becomes like that. Okay. So when the line becomes like that, we are at the global minima. Okay. Right. So that is, we'll know more today. Okay? So there are different activation functions. And I already told you that the output function is going to be sigmoid if the classification is binary. The problem is trying to do a 0 or 1 thing, right? Then the output node is going to be sigmoid node. If we are trying to do n number of classes, right? Classification on n number of classes, it's going to be softmax regression classifier. So if you want to do a regression problem, right, the last node is going to be linear regression. Right? You can take last node as linear regression. Linear regression, I'll show you. Now, if you don't specify activation function, it becomes linear regression. We'll see that, in the code. Right? So there are different activation functions, and this is the order. Sigmoid function is the least preferred hidden node. Okay, in the hidden layers, we least prefer sigmoid node as the node, and tan h is the next best one. Relu is the next best, and leaky relu is the best. I'm saying the best, but there are Selu and other nodes have came in, but when I prepared these nodes, right, this is the best node, best activation function for the hidden nodes. Why that is the best node? Let us try to understand why sigmoid is not preferred, preferred node for the hidden nodes. So till 2006 or 2010, the researchers were thinking that sigmoid node is the best node, and they are not getting good results on deep neural networks. And ultimately they found that leaky relu or relu is the best node. The reason is the activation function, sigmoid function, is going to be like this. Right? So if you take the linear combination of inputs, the output value of this function, right, 1 by 1 plus e power minus z, is going to be either, right, g of z is on the y-axis, 1 by 1 plus e power minus z, this whole thing is on y-axis, this thing is on x-axis. When you substitute a value which is greater than 0, right, you get a a value greater than 0.5, right? Let me try to show that on this one. See this? See, this is 0, right? A z value, linear combination greater than 0 will give you a value greater than 0.5. Okay? A z value which is less than 0 will give you a value less than 0.5. Okay? And when z becomes too big, what is it becoming? This is actually becoming flat. Z value is becoming too low, the linear combination is very small, then the equation, the line is becoming very flattened, right? You observe that? Right? That's the sigmoid function. But what is the problem here? If your z value becomes too big, right, the derivative of the cost function, the derivative of this activation function becomes 0. Right? This is one of the nodes. This is one of the terms used in the chain rule. You see the chain rule. See this dB by dj and dA by dg1. We are calculating derivative of the activation function. This is activation function. This is activation function. If you use sigmoid as the activation function, and if your z value is too high, when will it become too high? Either x values are too big or the values w's chosen, randomly chosen w's are too big. This z value will become too big. When it becomes too big, when you are doing back propagation, the back propagation may not happen because this derivative this derivative may become 0. When that becomes 0, u0 is equal to u0 minus alpha into 0, right? u0 is equal to u0, u1 is equal to u1 minus alpha into u1, alpha into 0. W0 is equal to W0 minus 0, W, like that. Wherever you chose W, it will stay there only. It is not that the algorithm reached global minima. Because of the weights, chosen weights are too big, the model is not moving. The model will be underfitted. Whatever you do, the model will be underfitted. And sometimes it works, sometimes it will not work. So that's the problem with sigmoid function as the activation function for the hidden nodes. Got it? So when z value is too small or too big, two places, right? It's going to have this problem of derivative becoming zero. Got it?
So how the derivative will become zero, sir, if the values are too high?
So derivative is nothing but slope, right? Derivative is nothing but slope, right? Slope of this line is zero. This line is also zero. But here there is slope, right? If the z value is close to zero, maybe negative or maybe positive, that time there will be derivative for this particular equation,
Yes, yes.
right? So when z value is too high or too low, the derivative will become zero. That derivative is a term in chain rule. That whole if you look at that, we have written those equations, right? So I think I can write again, but you are getting it, right? Any
Yeah,
question?
that the line becomes flat, right?
Yeah,
And then the slope
yeah.
at the
When the slope becomes zero, this derivative becomes zero, total derivative, because it's the multiplication of all those derivatives, right?
yeah.
Activation functions derivative is used in the back propagation, and activation functions derivative is becoming zero, slope is becoming zero. That way, the sigmoid function may not work well when the random w's are too big or too small. Okay, so that is one reason why sigmoid function is not that preferred node for the hidden layers. Okay, and then tan h node, right? Tan h is a other function, right? E power minus g minus e power z minus e power minus z e power z plus again z is the linear combination. So here the tan h is better than sigmoid because it actually gets the outcome as -1 to +1. In sigmoid, the value is going to be between 0 and 1. Okay, between 0 and 1. But here the values, the outcome of this equation is going to be between -1 and 1. Tan h function works better than sigmoid. No, the z value, you get a mean, right? When you try to calculate outcome of this, right, it's going to give you a mean of zero. Why mean of zero is going to be better? Because in a neural network, suppose that these are all tan h functions, and you got outcomes, and all those outcomes are actually distributed between -1 and +1. You have to calculate next node's activation, so the values are distributed evenly, and the weights, the network will move in a certain direction. If it is sigmoid function, right? If all are coming close to zero, the next layer will all become zero. Even whatever weights you take here, if all these outcomes are coming close to zero, this layer will go off and the network will not move. Tan h will actually make the network move little better than, or learning little better than sigmoid. Got it? Because of the distribution between -1 and +1, the outcome between -1 and +1, some may fall close to -1, some may fall close to +1, some may fall around zero. Even here also, if everything falls around zero, we may get that zero thing. But in tan h, right, that possibility is more, right? If the weights chosen in the previous layer are all close to zero, that network, that layer may give you values which maybe close to zero. Because I am saying the first iteration is going to be random weights, right? Because of that random weights, we may get these problems. Got it? Difference between tan h and sigmoid. Got it? Any questions? Okay. So in tan h also we have the same problem, right? You know, when you substitute z values, when z values are too big or too small, again it actually becomes flat, right? Derivative may become zero when z values are too big or too small. So the solution for this is, when you choose random values, the random value should not be too big or too small. Okay, we'll see that. You know how to that's whatever the concept we are talking is called as vanishing gradients. Okay, there will be exploding gradients and vanishing gradients problem. To avoid that problem, we need to choose the weights in a proper way. Right, the neural networks currently coming, like the TensorFlow and PyTorch, they'll do that. They'll do that internally, but we need to understand how these activation functions work, so that we can play with them. In some cases, tan h function is the one which is used. In RNNs, recurrent neural networks, we use tan h function as the default function for the hidden nodes. Okay, LSTMs and GRUs are there, but if you want to build a simple RNN, you will use tan h as the activation function. Okay, so here also we have that problem, but one problem it solved is when the network, the outcome, the hidden nodes outcome distribution is going to be evenly spread, or the mean is going to be zero. But on the sigmoid, right, it may actually go close to one or close to zero. If it goes close to zero, this network may go off. If it goes close to one and the weights are chosen, random weights are chosen too high, then also the derivative may not get calculated. That way the network will not work better, or the network will not learn. At some point in time it stops, even though the slope is not, it did not reach the global minima, the network will stop learning. So those are the problems with sigmoid and tan h. And they found a ReLU, a simple node, right, a linear combination. The ReLU function is that maximum of 0 and z, right? If the linear combination is negative, we take 0. If the linear combination is positive, we take positive, that whatever the outcome we get. So the function is going to be like this. The function's outcome is going to be like this. So rectified linear unit, we call it as rectified linear unit, is one of the best activation functions, work best in solving many problems. When value of z is 0, we take 0 or negative, ReLU actually gives 0, otherwise z. The function works for some neurons, the slope, okay, again the problem is there, but very rare, right? And here there are two problems. One is that at 0, right, there is no derivative. At 0 there is no derivative, and derivative for the function. And the other thing is, uh, when the linear combination is becoming negative, again the same problem will come. The derivative may become 0. But when you use ReLU, right, when you use ReLU in a neural network, some may actually become 0, some may be active, right? Suppose that these two, right, the first one and the fourth one are 0, right? The middle two are active, then that network will flow, right? The adjustment will go, right? Instead of stopping the whole thing, these two nodes will actually go forward and backward. And the next iteration, the weights are adjusted or weights are changed, right? So this will actually change. Okay, so next iteration weights will change. Why? Because okay, if it becomes 0, weights will not change. Give me 1 second. The ReLU activation function here, it gives 0. What will happen?
The factor corresponding to only that node will become 0, sir. But because other nodes have some values,
Other nodes will happen, but in the next iteration, sir, I'm thinking next iteration. Next
I'm also
iteration
referring to next
also this will not move, right? Because these weights are chosen randomly and those weights were not adjusted as part of back propagation. And for those weights, it will give 0 only, right? Only some nodes will work.
The weights will be same for any iterations, I will.
Yeah, they will not change. Once you get 0 here, right, these weights will not. In the first iteration itself, the random weights chosen are giving you 0 weight. That node will not move anywhere. That node will stay there only. Even though you have 4 nodes, only 2 will work. 2 will not work. First iteration. The first iteration is giving you 0. But generally, rarely it will happen. Generally, first iteration will not give 0. Okay, because the weights we choose will be chosen in a careful way. Okay.
When you say the weights become zero means the
No,
derivative is becoming zero, right? Not the weights.
no. What I'm saying is, you chose some 3 weights here.
Yeah.
You calculated the linear combination. It gave negative number. What will ReLU will do? ReLU will give 0 as the outcome.
Okay.
Right? When it comes, it gives 0, right? There is the next layer. This node is not useful because that 0 is multiplied with some weight, some weight, some weight, and added to the linear combination. There is no node at all. If it is giving 0, that means this node is not at all considered. If the same thing happening here also, right? You go forward while doing back propagation, there is no node there, right? So the back propagation will not happen. The weights coming into this node and this node will not get adjusted. Got it? Even though 4 nodes are there, 2 will be active and 2 will be working. Got it? No? Yes?
No, in the back propagation, let's say in the forward, when it becomes, let's say, top one and bottom one, they became zero. Their contribution to the next layer will be zero, but there are other nodes which are contributing to the
Network?
calculation of the valuation in the next layer. So
Yes.
they'll move forward. So there is no
Yes.
problem in the other nodes. But when we do backward calculation again, when the adjustment happens, because the adjustment, even though in the first layer whichever became zero, they can become non-zero, sir. Right?
No, when it becomes 0, right? There is no derivative for the in the chain rule. We are actually using activation functions derivative also, right?
Yeah,
Chain
it's not.
rule.
Yeah.
So when you're using activation functions derivative one term in the chain rule, the derivative also becomes 0. That way the weights will not get adjusted. W minus W minus alpha into derivative of whatever that whole cost function, right?
Can you please show us the derivative of this first layer, sir? Backward propagation. Backward propagation.
Yeah, let me try to write it down. So once it becomes 0, that's it. That node will not be considered anymore. Till that point, it would have contributed to for the learning. But once it becomes 0, right, it will not be considered. So the back propagation is going to be for this node.
So it will become zero for all the negative values. So until positive,
All the
then
negative, if it is giving negative value or the 0 value, it will take 0 only. If it is greater than 0, then only it will take the value, the ReLU activation function. Okay. So maybe I may not be able to show for this network, but if it is a simple network like this, right, like the one we have chosen, like this, right, then we can show, because writing a big equation is a bit difficult thing, right? Let me try to do that here and then try to understand. So when we have to calculate, right, suppose that this z value is negative, right, and this is ReLU activation function. Okay, if this is ReLU activation function, it will give you 0 as the output, right? So now we need to calculate this derivative, right? That derivative is calculated right? D Z1 by dW1 into dA1 by dZ1, right, into right, dZ by dA1 into dB by dZ into dJ by dB. So here, this is the activation function's derivative and this is another activation function's derivative, right? This is output node, so we are using sigmoid. This hidden node, instead of using sigmoid, I am using ReLU, right? So this activation function's derivative is not defined. When it is 0, you cannot calculate derivative of it. So this weight will not get adjusted. You know, that weight, whatever weight is chosen will stay there only. Got it? Or you can make this whole thing as 0. When it becomes 0, what happens? W1 is equal to W1 minus alpha into 0. Right? Like that, right? Here also it will happen. Here also, in this also, if it becomes 0 or negative value, it will become 0, right? So that weight will not get adjusted. So this node and this node, even though they are there, we defined it, the network will not use them. If it happens in the first iteration, generally in the first iteration it will not happen because the weights are chosen very carefully in the first iteration. Maybe after maybe 100 iterations or maybe 10 iterations, some nodes will get wiped out, but still the network will move. Okay, the network will learn. Got it?
So the output of this node will move forward or it won't move forward?
It won't move forward, right? It is like if this becomes 0 and this becomes 0, whatever weight going out of this should multiply that 0, right? What happens, right? The linear combination, right? W1 into X1 plus W2 into, maybe I'll say A1, A2. This I'll say this as a A layer, right? W1 into A1 plus W2 into A2 plus W3 into A3 plus W4 into A4, right? If the A1 becomes 0 and A4 becomes 0, these two terms are not going to be considered. Only these two terms are considered, right? In this network, or in this network, or in this in this node, any node, right? Either weight becomes 0 or the activation function's outcome becomes 0. That term is not considered. Right? Weight becomes 0, only the term will go. But the activation function's outcome becomes 0, that node will not be considered. That means even though you have 1, 2, 3, 4, 8, 8 plus 3, 11 nodes, because of the outcome becoming 0, 4 will go off and it will be like 7 nodes only. 7 node network. In ReLU, in sigmoid and tan H, this loss is going to be more. Loss of nodes is going to be more when compared to ReLU. Got it?
But how the weights will become 0, sir? Weight is not becoming 0, right? The activation
Weight will
function.
become 0 because when you are doing W1 is equal to W1 minus alpha into derivative, right? This sometimes makes your weight 0. That calculation may make your weight 0. Got it?
No, whatever initially we take, right? We won't take the zeros.
No, we
Right.
may not take zeros, but after certain number of iterations, right? What you do is you pass one record. I think I forgot to explain one thing. You have, suppose that you have 100 records, right? Suppose that you are taking one record at a time. You passed the first record, right? And did whole forward and back propagation. Second record, forward back propagation. Third, forward back. So 100th record, forward backward propagation, right? This is called as one epoch, right? Same terminology. In stochastic gradient descent we use it, right? That's called as one epoch. The second epoch, again you take first record, forward, pass, backward. Second record, forward, backward. This first record, second record is going to be random. Okay. So you are doing number of iterations. That means every time you are adjusting that. W1 is equal to W1 minus alpha into derivative of cost function with respect to W1. W2 is equal to W2 minus alpha into derivative of cost function with respect to W2. Like this. You're adjusting that. Now doing multiplying linear, calculating linear combination, substituting into ReLU or sigmoid or whatever, getting the outcome and going and trying to calculate y cap and j, and again you are coming, while doing back propagation you are adjusting weights, again doing forward, again adjusting weights. Got it? Now clear? Right, you are doing maybe 10 epochs. That means how many 10 into 10,000 iterations you, so 1,000 iterations you do if you are taking
So
one record at a time.
yeah, so if the weight becomes 0,
Hmm.
so there won't be a value coming out of that node or in the
Yeah,
node.
whatever value you take, whatever value the node is giving, that weight will be make it 0. So basically, what we the way we should understand it is, network understood that node's that node's contribution is not needed in a way, right? When you are doing regularization, what is happening? The sometimes some of the input
Weights,
features coefficients are becoming 0, right?
yes.
So that's the thing, when you have actually given put 100 nodes into maybe 10 layers or 5 layers, some nodes weights are becoming 0. That means that is not important. Learning, that is called as learning, pattern recognition.
Okay. So when the weights become 0, yeah, that's okay. But let's say in the first iteration we have taken some values for the weights
Uh,
and it is back propagating,
uh.
but the weights has not become 0, but the derivative has become 0.
That means we reached global minima.
Yeah. And going forward the weights will be same, right?
Weights will be same.
In
That
that
means we
case,
reached the place where we need to reach.
yeah, for that particular node.
Yes, and
And and the output from that node will be transferred to the next layer or not.
yeah,
It will transfer, but it will transfer the same value. Is that right?
same value. Yes, same W, same contribution. It is like there are 7 people working to make the output node succeed. Right? The contribution from some people is enough, and some people they need to learn. Right? That way it is the network is going to adjust.
Okay. Okay. Okay, sir.
Any questions? This whatever you guys are doing this discussion, right? This is very important. If you understand this, the CNN, RNN, transformer network, everything is based on this only. Gradient descent and this understanding. Good, right? Can I move on?
Yeah, and we discussed this applies only to the hidden layers, but is there a similar case for the output layer?
Same,
Like
and
we did.
output layer also same. No, same. This is one node basically, right? You are passing multiple values here. The whether you pass x1, x2, x3 or some nodes output, it doesn't matter. There are some weights. It is a linear combination. You have taken some activation function. Can be sigmoid or can be the softmax.
Yeah, the problem we discussed with the sigmoid, we were discussing it is the problem with only the hidden layers. Is that the problem applies to the output layer as well?
Okay, okay. What you are saying is, if the value is 2, yes, it applies to that one also. But when the hidden layers are working properly, you will not encounter that problem in the last layer. That's kind of, uh, many experiments they have done and they found, that's how it works. That problem stays even, if the weights are too big, are the outcomes from the this ReLU node actually gives you linear combination. If the really linear combinations are very big or very small, what happens here, this value will become very, that the sigmoid's outcomes will actually fall on the flat space, and again derivative becomes 0. If the derivative becomes 0, right, all the networks, right? So that will not happen until and unless these values will be calculated keeping y in mind, right? So the w's are getting adjusted in such a way that it gives a value that is close to y, or the cost is reduced. So that way, that mistake will not happen. That error will not happen here. The weights will be, sorry, the the outcomes will be generated properly. Okay, the initial weights will be carefully chosen. There are ways to choose initial weights. In that way, weights will not go explode, right? So these values will also be carefully given, because it is always looks into the cost function and calculated. That problem stays here, but that will not happen. Got it?
Yes, yes, sir. Go ahead.
Yeah, it is just that you need to visualize it, and think and understand. It is not, there is, we cannot show proof. It's going to be a big math. Show that proof.
Yeah.
Okay. So let me move on a little bit, and if needed, we'll have more discussion at the end of the session. Okay, this is a ReLU activation function, and here there is this derivative becoming zero problem is high here when uh, when compared to the sigmoid and tanh, it may be low, but still it is high. If you are getting um, out of 4 nodes, if your 2 nodes are giving zero or negative value, that is actually derivative is becoming zero. To avoid that problem, leaky ReLU, a simple math, right? So max of 0.01 into z comma z, right? So if you are getting z as -10, if you multiply 0. Maybe minus 100, right? 0.01 into -100 is -1, which is high. -1 is high compared to -100. So you take -1. So that way, what happens is this line becomes a little slant. Instead of making it a flat one, we made it slant. So in most 99.999% of the times, there will be derivative for this leaky ReLU. Okay, and only at 0, right? When z is equal to 0, that's when there is no derivative. Okay, so z is equal to 0 will rarely happen, very rarely will happen. Okay, so z is equal to 0 will happen only when weights are all 0 or the inputs are 0. All inputs will not become 0, all weights will not become 0. So getting 0 is a very rare thing. Most of the cases you will have derivative. So this is the best activation function. This is the leaky ReLU is the best activation function for the hidden nodes. Okay, so that those are the 4 basic hidden nodes are the activation functions, and we have more, but you can actually go through them and look at it. But leaky really works well. Okay? There is implementation for these ReLU, leaky ReLU, and all. Okay, I use ReLU generally. Leaky ReLU is the best activation function. Works in solving many problems, and the value of z is 0 or negative. Leaky ReLU function, you can actually change this number. You can actually play with this number also. It's a hyperparameter. You can change that number to make the model, maybe even slanter. If you put 1, right, it become 1 line. If you put 1, there is a problem. Can you think? Z is equal to 1, what happens to the activation function? Sorry, the max of 1 into z comma z. What
dz is
happens?
always constant.
Linear combination itself, right? It's a linear equation of your weights and inputs, right? It is not a non-linear equation. It is a linear equation. So the question is, can I take hidden nodes linear function? The linear regression has hidden nodes. If I take, what happens? Can I take the hidden nodes, the activation functions, linear function, linear regression? what happens?
dz will become 0, right, for everything.
No, linear equation means, all the weights are there. Suppose that all the weights are there, right? All the weights are not zero, non-zero weights, and their x's are there. You are taking linear combination here, linear combination like that, right? And then you are building a network. Output node is logistic, or if it is a regression problem, output node is also linear. So what happens is the network will not learn anything. Our network will learn. No, it's the wrong statement. Network will learn only the knowledge that a single node learns, right? So if you take all our linear regression, this one node what it learns, the whole network will also learn the same thing. Because when you take a linear equation here, right? Linear regression here, right? All these are linear regression. How is it adjusting the weights, right? The linear regression, there is a cost function, right? There is a cost function y minus y cap whole square sigma is equal to 1 to m, right? So now, when you take all these linear equations, whatever random weights you take here will reach to one place, right? The same place these weights also will reach. These weights, whatever random weights you take in all the layers, all will reach to same place, right? So, so, so for this node, the same cost function. For this node, the same cost function, right? Because these are all linear functions, right? These are all linear equations. Ultimately, what will happen is all the weights will reach to the same place. Either you use one node or 100 nodes, it doesn't matter. If you take linear function, it is going to learn one node's learning only. I don't know whether I was able to explain that properly or not, but uh, that's where we take the activation hidden layers activation functions, nonlinear functions, because each one will learn a different pattern. If you take nonlinear function, you pass different weights here, this will be a different curve. If you pass different weights here, this will be a different curve. If you pass different weights, it will be a different curve. If you pass different weights, it will be a different curve. But if it is a linear function, this is a linear function, what happens is initially it may be a different line. Initially, one may be like that, one may be like that, one may be like that, but ultimately everything reaches to one place. All these lines will reach to one place. When I say all the lines reach to one place, all weights will become same. Did you understand the concept? The hidden layers activation function should be non-linear. If you take linear functions, either you use one node or 100 nodes, it will be learning the same thing. Got it? Or should I try it in a different way to explain? Got it? No? Okay. So let us jump into the code and try to do something. I think I did not install the TensorFlow on this Windows machine. Yeah, I didn't do it. So maybe tomorrow, right? I'll go into the Unix machine and then I'll show there. But today I'll show you some code, right? So in the Anaconda, you need to install TensorFlow 2.0. Okay. So Conda, let me try to install. Okay, I need to explain that also. There are two variants of TensorFlow, right? One is that GPU, right? If you have GPU in your computer, okay. The point is to do either TensorFlow or PyTorch, we should have NVIDIA GPU. I'm not asking you to buy GPU or computer with GPU, but the basic requirement to do the deep learning, we need to have a computer with NVIDIA GPU. Okay, so can't we do anything without NVIDIA GPU? Yes, we can. I'll show you in a minute. Okay, so there are some laptops at around 60,000. And here what we have is where is that? I wanted to show some GPU models also. 2060 and 2060, 2080, those laptops are coming now, right? They are around 80,000, 90,000. Okay. So NVIDIA GPU is definitely needed, right, to do deep learning. You can do it on your normal laptop also, but it will run very slow. On a normal laptop with CPU, it may take 3 hours, but the same program will run in 10 minutes on the NVIDIA GPU computer. So why NVIDIA GPU is needed? If you look at the calculations here, they're all matrix manipulations, right? So the activation function outcomes are all matrix manipulations. So these matrix manipulations will run fast on GPU. Gaming computers will have GPUs, and even in our normal Windows machine, sorry, normal Intel computer also will have GPU, Intel GPU, but that GPU is not useful because the TensorFlow and PyTorch frameworks use CUDA, a framework built by NVIDIA, guys, to do these vectorized, uh, implementations. Okay, so you can install TensorFlow like this, but there are two variants of TensorFlow. And if you go into TensorFlow install, right, they'll actually show you that there is a TensorFlow and TensorFlow GPU, two variants. So see this here, current stable release TensorFlow, right? TensorFlow GPU is there. So you pip install TensorFlow will actually install normal CPU version of the TensorFlow. But if you want to install TensorFlow GPU, right, you should be doing TensorFlow hyphen GPU. Let me show you that. So this one, right, it is installing 1.1, 1.4, right, 1.14 version. But if we have to do there's a big trouble here. So when you're installing with TensorFlow, see this here. So Anaconda install -c Anaconda TensorFlow. That's how you need to install. For GPU, you need to put TensorFlow -GPU. I think they changed it. Okay, for GPU, you should be installing like this. Where is that? I'm unable to see. Let me. Yeah, this is the command. Okay. So Conda install -c Anaconda TensorFlow GPU. I was saying that I am going to use a Unix machine, not the Windows machine, because if you want to build computer vision modules, Windows machine will not work. Okay. when you are trying to do these deep learning models for computer vision and NLP also. Okay, NLP Flare like packages. If you try to install and try to use it, right, it will ask for VC++. But when you install VC++ also, it will create multiple problems. So it is always suggested to have a Ubuntu machine to practice on your laptop. If you don't have it, don't be worried. We have Collab, right? Let me go to Collab. Collab, right? You can open, right, when you double click on IPython notebook, right, open with the Google Collaborator, it will ask. I think you already know. But when you open it, it will allocate GPU here. We can actually ask for GPU also, but there will be limited time. And in a month, you can use maybe, maybe 20 to 40 hours, I think. I didn't really remember. Right. It will show GPU. There is a Pro also, faster GPU. So you can pay and use. They're changing slowly, automatic. Just learn more. See that $10 a month. So $10 a month is not a big deal, right? So you can, instead of buying a laptop, we should actually take this and use it. Longer run time. So in the free version, right? Every 1 month, every 1 hour, it will actually stop. You need to actually do some activity there. Rather, you need to reconnect. Okay, so you can explore this option. This is a new option. This is one way to run your deep learning code. The second thing is Kaggle kernel. And Kaggle kernels is also a free one, right? You can actually create your notebooks here and work on it. So I used the Jupyter notebooks from the day one because these are all guys who are actually following the same whatever, right? You can actually load data here. So if you see this, it is connecting. I think I should take this, maybe we should take it for the employees at least. So you can actually upload files here, right? Or you can actually connect to your Google Drive. You put your data in Google Drive, you can mount it, right? You mount it and it actually takes it. See this? So you can see the data, right? And Google Drive you can see. Okay, I need to run this. If I run it right, it will give me a code there that I need to accept, right, like that. It will take everything, all permissions. Now I need to put it here, say enter. Right now you will see your Google Drive here on the left side. Now whatever the path you have, you can actually copy it and paste it here, and then you can use it. Yeah, this is the drive. See that? I refreshed and then I can see the drive. So all my drive is visible here. You can just take the, go here, copy path, put it here, and you can use it. Okay, so like that. So for now, while learning, at least for next 2 months, use Google Colab and try to do whatever you can, and then see do we really need to buy a laptop or not. Even for computer vision, the object detection models also you can use Google Colab. I'll show you how to use it. Okay. So I have, my laptop is GPU one, so I'm going to use mine, right? So if you guys are, there'll be these versions installed and everything, and collaborate. You can install new versions also if you want, all the software you want. It is like in the right in here. If you say, so if you add a code cell, right, and say, right, like that, you do it and press enter, it will install. It will install, spaCy it is installing, right? So whatever modules you want, you can install and use it, right? Google Colab is very convenient, I would say. And then if you want, right, you can go with Pro and play with it. Okay. So font size, automatic trigger code. It will actually use TPUs and GPUs both. TPUs are produced by Google guys. There will be computers with TPUs also in coming years. They are trying to optimize the GPU for the deep learning purposes. Okay. Any questions on the hardware requirements and the Google Colab?
So how to use the Ubuntu on Colab?
Ubuntu, you cannot access operating system on Colab. They'll give you
You mentioned.
notebooks and you will use it, and you can download. You can pickle the model, and pickle in the sense there are ways to save your model, and that gets saved onto your drive, Google Drive, and then you download it and you download the program and migrate it wherever you want. Like that you can use.
How can I know that this is running on the Ubuntu? The Colab.
Definitely they'll run on Ubuntu only. Rather, the deep learning models will not work. Sorry, these computer vision and NLP models will not work. When you try to make them work on Windows machine, right, you'll understand the problem, what I'm actually talking. So we will see object detection models, right? You try to execute them on Windows machine, you will see the pain.
No, that I got, but when we open a new Colab instance or whatever on the cloud,
Yes, and this is cloud only, yeah.
yeah, how can we know that it is running on Windows or Ubuntu? Is there a way to set
You
run
want
Windows?
to see operating system on which it is running, operating system and version kind of a thing, right?
Not exactly, but how it knows it should be run on Ubuntu or it should be run on Windows.
This is built by Google guys, right? They are the ones. TensorFlow is from Google only. I may not have got your question, but the owners of TensorFlow is Google, and they are giving us
No,
the
based
environment.
on what it runs on Windows and based on what it runs on Ubuntu. I may not need to know, but
Yeah,
so
it is not about based on what. The best environment to run deep learning modules is Ubuntu or Linux.
that
Any
I
Linux.
understand, but how it decides is the question, sir.
The guys who built it, right? They wrote code in such a way that it runs on Ubuntu well. See, somebody invented it, somebody built it, right? The code they wrote, right? It's like some music players will work on Windows and some will work on Linux and some work on Mac OS. Right? How does that it work? Because the person who built it wrote
No,
code on
I'm
that
not
particular.
telling how does it work.
Hmm. No, I didn't get your question, I think.
Yeah, that's I think.
The best environment to work with deep learning and NLP modules is Unix only.
Yeah, that's right. But when
That
we
you got
open a new collab window,
it.
so based how it decides it's
No,
going.
it is not deciding. It is already there on Ubuntu only. Ubuntu or Linux. The Google is using Linux machine to host these cloud services.
Okay. So it is not using the Windows at all. So even for
No, it
any
will not.
small
It will not because when you work on your machine, the Windows machine, you are unable to do the deep learning models for computer vision and NLP. Why would they use, right? As a user, I know that it is not going to work on Windows. There's an inventor, why that guy will use it. Even the servers they provide for deep learning are all, the Ubuntu machines only, Linux machines only. Even on, if you go to AWS, somebody don't know that, are people who did not explore much on deep learning try to use Windows machines. In one of our clients, that's what is happening. We asked for Ubuntu machine, they asked why. There are many big data scientists in that company. It's a big company. So that's how the industry is. Got it?
Yeah. In simple terms, this whatever we are doing on collab, it's on by default. It's on Ubuntu, not
Ubuntu
on.
only. And you don't care. Whatever the environment, until and unless the programs are running, you don't care, right? So
Yeah, I was thinking like it could be on both, but
no, no.
we need to tell
Definitely
somewhere
no.
that
No Windows. అసలు మీరు no question అండి. No question at all of Windows.
yeah, that was the gap. I was actually thinking it could be on both.
No.
So in some way we have to tell, okay, run on Ubuntu for this.
Machine learning you can run on Windows, but deep learning you cannot. And when you cannot, the servers will definitely be on Linux only. Backend, the OS is Linux only. But we don't care because the interface is very convenient to use, right? So we don't care. But on a local machine, on your machine, you want to do all that using artificial intelligence, you should definitely have a Ubuntu machine because Ubuntu has got much support, community is there, right? And you have some issue, you type, you get command, you execute it and make it work, right? So managing operating system is also easy in Ubuntu. Got it? So those are the hardware requirements and the software requirements. So if you have a GPU machine, right, you do like that and press enter, right? If you don't have, you do that. Without GPU, do not do, you don't do this GPU thing because it gets, that whole environment corrupted. So I would recommend you to create environment first, right? Did I show you environment creation? So in an Anaconda or in a Python, whatever you installed Python or Anaconda, it is called as base environment. In that base environment, you can create additional environment. What is the environment? A container where you can install the softwares you need. Okay, so it is like let me try to draw and show maybe a bit. So this is good collab. That paid version is going to be definitely good, I think. Okay, so when you install Python or Anaconda, you can think that as a big box. Okay, where you have all the softwares installed. Pandas, NumPy, right, Spassy, all those softwares installed. But if you want a particular program, right, a program or a module that actually wants to use specific versions of pandas, right? Pandas current version may be 20, right? You want to use 18, right? NumPy may be 17. You want to use NumPy 16, right? So you can create an environment, an additional small box inside this, which will have all the versions you wanted. Why do you need it? When you are doing computer vision, right? Some modules already pre-built are present in the internet. When you have to use those modules, right, you need to have specific versions of the software, especially OpenCV. OpenCV, you need to install specific versions for specific modules. So in that case, right, you need to have specific environment created. Any number of environments you can create with different versions of the software. Got it? Got it? Virtual environment you call it as. Got it? Any questions? Got it? So to create a virtual environment in Anaconda, the command is conda create -n, the name of the environment, right? Name of the environment, I'll say Tflow, right? And then while creating this environment, do you want all the software, all the modules that are present in Anaconda or not? So that is ANACONDA, Anaconda. And I want all the modules that are present in Anaconda along with this particular environment, you should say. And then Python version, which version you want to use, right? You can say Python is equal to 3.6 or 3.7 or 3.8. I will say 3.8. Okay. When I say enter, right, it will actually try to resolve the repository and get all the modules, right? And then it, oh my god, I closed it, sorry. And create -n Tflow Anaconda Python 3.8, right? It resolves the repository and fetches all the modules and asks whether we want to install it or not, install all those modules or not. No, the commands are same, whether it is Ubuntu machine or Windows machine, commands are same. Okay, but in real time, we want to work on modules. They'll give a laptop, right? Definitely, we should have this hands on. And maybe Shishram was trying to ask that question only. If you are habituated to use the collab, you may not know how to use Python and how to use Ubuntu and how to install software and work on the individual machine, right? So I think once you are good with the subject, then you try to buy a laptop or do whatever, right? So instead of trying to buy something upfront and doing it, practice a little bit, get a little hold on it, then buy it. Then you'll know which one to buy and which one not to buy. Okay. So I can install, if I say yes, right, it will install. I'm not going to install it because on Ubuntu machine, right, I'll show you. Tomorrow I'll show you how to install Anaconda, the TensorFlow, and then we look into the code, already written code on digit recognizer and all that. So we'll
So in the command we said Anaconda to install all the libraries in Anaconda.
present in Anaconda.
Yeah, so will it takes all the latest versions of the libraries, or
It takes the versions which are dependent on Python version we gave. Python 3.6, if you give 3.6 based Anaconda, it will take.
yeah, but it could be two versions which are supporting, right?
Yeah, it will take latest only. That's the use of using Anaconda, right? So Anaconda is always facilitating the dependencies and version conflicts, right? It's solving all those version conflicts.
I think we can also say, like, in the initial step, use this Python version and then install the individual libraries
We can.
or the specific version.
What you are saying is, can I do this way? Anaconda, sorry, Conda, create -n Python. Only Python you want to say, 3.6. And then you want to individually install modules. Or if you don't say that, right, it will just create the environment. Then you need to install, Python, base Python it will take, I think. I did not do this experiment. The name. I don't recommend, individually installing modules because you will get trouble. Experiment, you will know the problems and then in real time, right, it will help you. In interviews also it will help you.
But
Try
if
to install
we want
individual modules,
to,
you will get into trouble.
but if you want to have a specific version, then we have to do, right?
Yes, and
As you said.
in real time, right, you need to have specific versions for different things.
Yeah.
That some Python is not fully mature as Java, right? You do, for example, I'll tell you is I showed you one application, right, where we were actually generating graphs and all. That we need to, for that, right, we need to generate a exe file. It's a standalone application. We struggled a lot. Around a week it took to generate exe file. There is a PyInstaller software, but that will not package everything. We need to create different folders and experiment with different things, and then we found it. And different, it works on Python 3.7 only. It will not work on 3.6 or 3.8. So it will be a trouble. Building a model is one thing, and then trying to deliver it is another thing, especially for the standalone application. And we did this speed detection for NTPC, right? So there, the models will not work on Windows machine. First problem. Second thing, we should definitely have GPU. Only 3 guys in our team have GPU machines. On those only we can actually run or do whatever we want. Rest of the guys can help doing labeling and all that other stuff. Right. So in there also we were actually we have used some software called this OpenCV and GStreamer. Though there were conflicts between those two, but Anaconda is not supporting it. Individually we need to install, and we had to struggle a lot. So these kinds of problems will come. But anyway, we have to face them. Try to experiment. Got it?